Okay, so we're asked about a spacecraft circling the Moon at a distance 384,000 kilometers from the Earth, communicating by radio, and how much time elapses between the sending and receiving of a signal. So first of all, we'll assume this is one-way communication. So here's the Earth. It's not a very good Earth. Here's the Moon, not a very good Moon. And orbiting the Moon, here is my spacecraft. Also not a very good spacecraft. Okay, so drawing is not my strong point. But the point that we need to understand here is that we're being asked a very simple question, because given this distance, we're asked for the time of the signal to be received, and we know that the velocity of light, and any velocity, is given by distance divided by time. In this case, we want the time, so we can cross-multiply the equation, multiply both sides by multiply both sides by t, and then divide both sides by c, so we have that the time is equal to the distance divided by the velocity. Then the only other mistake we might make here is if we try to substitute directly a number in kilometers, because the assumption here, if t is in seconds, the velocity of light is in meters per second, and therefore the distance should be in meters. So we need to convert 384,000 kilometers into meters. And we do that by remembering that a kilometer is equal to 1,000 meters. Therefore, 384,000 kilometers. We just make a direct algebraic substitution, kilometers for 1,000 meters, and we see that we have 384 million meters. So the time will be given by 384 times 10 to the 6 meters divided by 3 times 10 to the 8 meters per second. Let's make sure we haven't made a mistake. The meters will cancel, and we have 1 over seconds, which is simply seconds. So we will have a number in the correct unit, and we just plug this into our calculator and find that the time delay from somebody speaking on the Earth and then being heard in the rocket ship is 1.28 seconds. Outline your answer nicely for the person who has to mark the problem, and we're done.